This is the database presentation by Zachary Stassa. Databases are one of the best ways to organize data. Databases are extremely helpful at assembling information in convenient or helpful ways, such as through grouping based off different traits. Some ways databases can list or present information is alphabetical or numeric in ascending or descending order. Databases have a wide range of utility as they are useful in a variety of contexts. Databases are very useful in recording company transactions to provide a convenient way to report financials. Databases are useful for logistics because they can help track things such as company inventory. Databases can be used to track employees and their activity or productivity as well. Databases act as a time-efficient way to manage data. Databases can also allow for data to be analyzed with ease. Databases that are a collection of arbitrary data can turn the data into valuable information, since it can be aggregated and analyzed in a way to find patterns and statistics, which could be useful. To construct a database, one essential thing is to figure out what data needs to be collected and how to record it. Another thing to consider is where the database will be located and how will it be managed, or what maintenance will be applied to it. A purpose for the database will need to be outlined as well, so there can be a clear goal set to be accomplished. Two different database structures are flat file databases and structured databases. Flat file databases use plain text in order to contain the recorded data. Structured databases use things such as tables in order to contain the recorded data. Structured databases are often preferable to flat file databases, since structured databases are able to much more easily be used in programs which could automatically update or read from the tables. Structured databases use SQL, or Structured Query Language, to allow programs to communicate with the database. There are 4 different relationship forms in databases: a one-to-one, one-to-many, many-to-one, and many-to-many. One-to-one is when a database entry has a relationship with another entry. One-to-many is when a database entry has a relationship with many different entries. Many-to-one is when multiple database entries have a relationship to one entry. And lastly, many-to-many is when a set of database entries have a relationship to another set of database entries. The different forms of database system management are hierarchical database systems, network database systems, and object-oriented database systems. Hierarchical database management is similar to a tree organization of data. Network database management is similar to hierarchical database management, though it is more interconnected as files are linked to from multiple places. Object-oriented database management is when data is communicated through objects. PostgreSQL is a structured database which is open source. In addition to supporting SQL, it also supports the use of JSON querying. PostgreSQL is a widely used database for many applications and websites. The database works best with Linux, Apache, and PHP, with programming languages like Python. PostgreSQL works very good as a way to keep track of transactions. Some PostgreSQL hardening recommendations are physically separating databases to reduce the risk of multiple systems being compromised in the event of a possible breach. Avoiding to allow connections from external sources to reduce the risk of a successful attack, as external connections are going to open up a wide surface to attack. And lastly, for the verification of data, use hash encryption as opposed to encryption that can be decrypted to make data more secure. And with the end of the presentation, here are the references.